Hi guys, Mr. Robeson here. Today we are looking at the beginning of our next unit, Unit 3, which is on probability. So we're going to take a look at what probability is, what's a probability distribution, and we'll talk a little bit about what expected value is. All right, so what is probability? Well, the basic definition is the likelihood of an event. All right, so it's some sort of measure of the likelihood of an event. We often will think about it this way. It's the number of ways the event can happen divided by or over. We aren't usually going to use the dividing. We're actually just going to write it over the total number of things that could happen. You've probably worked on probability before in some other class, right? We're going to start pretty basic here. So things about probability, well, we usually use this notation. Probability of an event, or probability of something like A, or probability of, we can use the letter E for event. We usually use capital letters in there. If we're talking about like rolling a die, we could say what's the probability of getting a 1, or what's the probability of getting a 3, whatever. So about probability, so the probability of any event is greater than or equal to 0. Right? So it's always positive, it can't be negative. It can be 0. That would mean that the likelihood of it happening would be 0. It was not going to happen. All right? So it also has to be less than or equal to 1. So the probability equals 1 means it will happen. So right in the middle is probability equal 1/2 or 0.5. It's 50-50. Maybe it'll happen, maybe it won't. All right? So here's an example. We're going to roll a 6-sided die. So again, dice means 2 or more. Die means 1. So we're just going to roll one of these guys here. So just this one's being rolled. What's the probability of rolling a 5? So we could say this is the probability of getting a 5. Well, if we look at our definition here, the number of ways that the event can happen, there is one way that 5 can end up on top. There's only one 5. If there were multiple 5s, then there'd be more ways. There are 6 total sides on this die. So there are 6 total possibilities. So we get 1 out of 6. If we wanted to, we could divide. So we can stop here, that's fine. But we can do 1 divided by 6, which gives us 0.16667. If we wanted to, we could multiply this by 100%, remove the decimal over twice, and we get 16.67%. All right, so we can write these as fractions, we can write them as decimals, we can write them as percents. So I'm going to put that down here. So fractions, decimals, or percents. All right, so any of those are probabilities. What's the probability of rolling a 1 or a 3? Well, one side is 1, one side is 3. So probability of 1 or 3, that is our event. There are 2 sides that we could get that are winners, 1 and 3. There are still 6 total sides. There's our answer, 2 out of 6. You do not have to reduce fractions in this class. You can just leave it right at 2 out of 6. All right, so here's another example. We have 28 students in a class, 16 are girls, 12 are boys. What is the probability a randomly chosen student from the class is a girl? So if we close our eyes, spin around a few times, and just point at a student, what is the probability that it is a girl? Well, there are 16 possible girls out of all the possible students, so not just out of the girls. So out of 28, so we get 16 out of 28. There's our answer. Done. All right, probability distribution. I think there's supposed to be something else in this slide. There it is. It's all possible outcomes and their probabilities. All right, so when we're talking about rolling a die, we could get 1, 2, 3, 4, 5, or 6. The probability of 1 is 1 out of 6. Probability that we get a 2, also 1 out of 6. There's 1, 2. Probability of 3, 1 out of 6. Probability of 4, 1 out of 6. Probability of 5, also 1 out of 6. And the probability of 6 is 1 out of 6. This is what we call a uniform distribution. All the values are the same. All of them have the same probabilities. All right, down here, we're no longer uniform. So we're looking at the students in AP Statistics. We've got 33 juniors and 64 seniors, which gives us a total of, let's see, 97. So the probability of getting a junior would be 33 out of 97. The probability of getting a senior would be 64 out of 97. All right, so these are both probability distributions because they give us all the possible outcomes and their probabilities. All the outcomes, 11th grade, 12th grade, and their probabilities. So that's what makes a probability distribution. All right, so we're going to make now a probability distribution from a hypothetical bag of Skittles. So I opened up this bag of Skittles and they fell out all onto my desk here, and I just started counting them. So we had 16 reds, 8 orange, 12 yellow, 14 green, and 10 purple. Some people claim that these are brown. I still claim that they are purple. Right? It's grape. Grapes are purple. So we first need to know what's the total number of Skittles we had. So we got to add all these up. So these two together make 20. These two together make 30. So that's 50. Plus 10 more is 60. So we get 60 total. You can just add straight across if you have a calculator. So now the probability of red would be 16 out of 60. Probability of orange would be 8 out of 60. Probability of yellow would be 12 out of 60. Green would be 14 out of 60, and purple would be 10 out of 60. All right, we usually don't have to fill this in, but if we would, it would be 60 out of 60 because those are all the colors we could get. What's the probability of reaching into the bag without looking and getting either a green or a yellow? All right, well, there's two ways we can do this. We can add up the green and the yellow. So it'd be probability of green or yellow. I'm just going to put the first letters. Would be 14 for the green plus 12 for the yellow out of 60, which is 26 out of 60, like that. Or we could have done 14 out of 60 plus 12 out of 60 and gotten 26 out of 60. So either way works. So we add up the two probabilities. So or means you can add up the probabilities as long as the two options don't overlap. All right, we'll talk about overlapping in a later video. All right, what about the probability of reaching in and not getting a red? So we could add up all the colors that aren't red. So it'd be 8 plus 12 plus 14 plus 10 out of everybody, 60. So that'd be 20, 34, 44. Or we could do 60 minus the 16 that are red, which gives us 44, everybody else, out of 60. All right, so we can subtract. So we could do like 60 out of 60 minus 16 out of 60, and this is just 1. All right, but you can just think of it as the total minus whatever we're not looking for. So not red. Red was the 16 here. We can just subtract that, and that gives us the 44. Or if you want to do the other way, if it's easier for you, just say, okay, well, we got if it's not red, it's orange, it's yellow, it's green, or it's purple. And we add all those up, and that gives us 44 out of 60. So that is how we do the not problems. All right, so each of these have a special name. So the or problems are what's called the addition rule. All right, so the probability of events A or event B is the sum of the two probabilities. So that means we are adding. That's why we call it the addition rule. So the probability of rolling a 5 or rolling a 3, we could say is the probability of 5 plus the probability of 3, which is 1/6 plus 1/6, which is 2/6, which makes sense because there's one way to get a 5, one way to get a 3, so two outcomes out of the 6 total outcomes. So that's how the addition rule works. Complement probability. So when we're talking about the not probabilities, that is the complement. The two things complement each other. Between the two of them, they cover everything. All right, so the complement is 1 minus the probability of A. So the complement of A is 1 minus the probability of A. It's usually easiest to do this with percents. Think about percents. So if the weatherman says that there's a 30% chance that it will rain today, what is the probability that it will not rain today? Well, these two things should add up to 100%. So we can do 100% minus 30% gives us that probability of it not raining is 70%. Right? 70% and 30% add up to 100%. They are complements. All right, last thing. So let's see, expected value. So there are 5 colors in a bag of Skittles, and suppose you know that there are 60 total Skittles in a bag. If Skittles colors are uniformly distributed, so not like the bag we got, how many of each color do you think there will be? Well, that means there should be the same of each. So 60 divided by 5 is 12. All right, so we should get 12 red, we should get 12 orange, so there should be 12 of each. All right, but what we actually did there is we took the probability of any color, say red, and we multiplied it by the total. Right, so we said the probability of red, there's 5 colors, so it should be 1 out of 5 times the total, which was 60, which gives us the 12. So we can say that this is the probability of whatever it is we're talking about, and this is our sample size, n. So the expected value, which we often use E of x, the expected value of whatever the variable x is, the expected number of reds in this case, is the probability times the total. I'll write it out in words here. Probability, of whatever x is times the sample size. And that gives us how many we expect, the expected value. The number we expect of that event, whatever event we're talking about, like event X. X could stand for whatever we want. So here's an example. Suppose we took a sample from a large company and found that 65 out of 80 employees have an individual retirement account, or what we call an IRA. If there are 800 employees in the entire company, how many would you expect to have an IRA? So the probability of IRA is 65 out of 80. All right. Our sample size here, the number of people in the country or company, is 800. So that means the expected value for the number with an IRA is 65 over 80 times 800. All right, so the 80s are going to cancel out here and leave us with 1. 1 0 is 10. 10 times 65 is 650, or you can type this in your calculator, 65 divided by 80 times 800, and we get 650 as our expected value. All right, and that is it for today. So we went over basic probability, what a probability distribution is, the addition rule, complement probability, and expected value. Check on the Google Classroom for your homework.